Hello, in today's video, we are going to be covering IXL Assignment TWW, Constant Rate of Change. As per usual, before we get into practice, let's do a brief review to warm our brains up. All right. In order to talk about rate of change, we're first going to talk about another rate, and that is unit rate. Unit rate is something you have already learned. Unit rate is when you find the rate of change when the rate is per 1. All right, some examples of that. That would be like miles per hour. If you're tracking speed, it's how many miles per 1 hour, per 1 unit. If we're talking about grocery shopping, the bananas and the apples may be charged per pound. So the price per 1 pound of fruit. So unit rate is whenever the rate is for a single unit. Now, rate of change sometimes does end up being a unit rate, but not always. The main thing to know about rate of change is that is a ratio, so a relationship between your X and your Y values. So it's between two different sets of information. And it is recording how much your rate, so whether it be your speed, whether it be your cost, is changing over time. And that change could be an increase, that change could be a decrease. All right. Now, let's do a problem to refresh our memory on what unit rate is. So we know that unit rate is finding the rate per 1 single unit. In this scenario, we learned that over the course of 3 hours, Maria walks 12 miles. We want to know how many miles does she walk per hour. All right, let's annotate. Let's mark up our text here. We want to know how many miles she is walking per hour. That right there is helping us set up our ratio, helping us set up our fraction. I'm going to just label it. I'm going to abbreviate using M for miles and H for hours. So we want to know how many miles she walks per hour. Therefore, this is the way our ratio, this is the way our fraction needs to be set up. Well, when I read this, we know that she walked 12 miles over the course of 3 hours. That right there is our ratio. But to find the unit rate, we need to simplify our fraction so it is over a unit of 1 hour, no longer 3 hours. Well, we can simplify that fraction by reducing it by 3. And we have 4 miles per 1 hour. Another way we can write that is 4 miles per hour. That is our unit rate. That is how much she is changing. That is how fast she is walking every hour. All right, let's take this information and especially the main part about how to set up our ratio, and let's transition to IXL and make sure that we can also find the rate of change, not just our unit rate. All right, here we are on IXL. We are on assignment TWW, finding the constant rate of change. This graph shows how the distance Allie has cycled depends on the number of trips she has taken to work. All right, I'm going to read my graph here real quick. It's the total number of kilometers Allie has cycled. My y-axis is the total distance cycled in kilometers. My x-axis is the number of trips to work. Okay. Now we want to find that rate of change. So it could end up being a unit rate, but that rate of change is a little bit more than that. It's how much our rate, in this case, is increasing because my line goes up and to the right. So it's an increasing rate of change. And if we look very closely, it tells us that we want to know how many kilometers per trip. Ooh, that's a little winner right there. That's going to tell me how to properly set up my ratio. So it is kilometers per trip. If I look at my graph, I notice that kilometers is my y-axis and number of trips to work is my x-axis. That information is going to ensure that we can get everything lined up properly. We don't want to get any of our numbers backwards. All right. Well, before I can figure out how much this is changing, I need to select 2 points on my graph so that way I can determine how much it's increasing. Because if I just have one single point, I mean, great. That would tell me, you know, how many trips compared to kilometers for that one single day, but I'm wanting to know my rate. I'm wanting to know how much it's changing. So we need to select 2 points. It doesn't matter which 2 points, because with it being a straight line, that means you have a constant, so a not changing rate of change. So any 2 points will do. All right, let's select this point right here at 0, 6. And then I'm just going to choose the next one I see, which is at 2, 8. All right, first, let's find how much our kilometers are changing. She started off at 6 kilometers and has increased 1, 2 kilometers. So from the first point to the second point, she increased 2 kilometers. Now we also need to know how much the trips increased. Well, her trips, that's our x-axis. So now we're looking horizontally. She started at 0 trips and went to 1 trip. Look at that. Is that already a unit rate? Do I need to do any simplifying? No, it's 2 kilometers per 1 trip. So 2 kilometers per trip. And it wants me to write my answer as an integer. So we would simplify that fraction. 2 over 1 is just 2. All right, let's try another one. This graph shows how the total number of stamps Brett has in his collection is related to the amount of money he spends on actual stamps. All right, when I read this graph, I see that it is the stamps in Brandt's collection. I have my y-axis, which is the number of stamps, and my x-axis, which is the money spent. Okay. We want to know what is the rate of change, and we are trying to find stamps per dollar. That is critical. That ensures that we set up our ratio properly. It is stamps per dollar. So stamps per dollar. Now let's look at the labels on our graph to make sure that we line everything up. I see money spent, so dollars. Money spent is my x-axis. And then the number of stamps is my y-axis. All right, now that everything's set up, let's pick our 2 points and actually determine our rate of change. I'm going to pick different points this time. I'm not going to pick the first one just to make it a little different. I'll pick the second one I see. All right, this is a good one right here. The reason I went all the way to 40/40 is because I want to make sure it's where it crosses a grid line perfectly. I don't want to estimate and say, ooh, I think that point, like this one right here where my red laser is, I think that point's at 30, 32, but maybe you could say it's at 30, 33. We don't really know who's right. So you want to pick a point where you don't have to estimate, you know its exact value. And this exact value is $40 for 40 stamps. And I really don't have any other good points, so never mind. I'm going to have to go back and pick that very first one, because when I look the rest of the way up, oh, never mind, there is one right here. See, sometimes it can be a little tricky. You got to look really closely, especially on a computer. So we have one at $80, 70 stamps. All right, let's calculate our rate of change. So first, I'm going to start with the numerator, which is stamps per dollar. So I need to see how much the stamps is increasing. The stamps is our y-axis, so we're going to be looking vertically, how much our stamps increase. Well, we started at 40, and it goes up by 10, so we go up 10, 20, 30. So from 40 to 70, we increased 30 stamps. Now we want to find the cost, so that's along our x-axis. So now we're going to move vertically. So we started at $40, and again, we're counting by tens. So we go up 10, 20, 30, 40. All right, from 40 to 80, we increased $40. All right, now we need to simplify that, because if I look at my label, it wants to know the stamps per dollar. That's telling me it does want my rate of change written as a unit rate. It wants my rate of change to be per $1. First, I'm going to simplify it because that will make dividing easier. 30 over 40, I can reduce by 10, and that becomes 3 stamps over $4. Now we need to completely divide, because if we look closely at our directions, it tells us that it wants our answer either as a decimal or as an integer. Sometimes, you know, fractions are allowed, not in this case. All right, let's divide this. So 4 into 3. Well, 4 can't go into 3 at all, which means we need to turn this into a decimal. Add that decimal point and a 0. How many times can 4 go into 30? 7 times? And 4 times 7? 7, 14, 21, 28. 30 minus 28 is 2. I got to keep going until I either hit a repeating factor or I have no more remainders. We add another 0 and bring it down. How many times can 4 go into 20? 5. And that goes in evenly, so no more remainder, which means our final answer is 0.75 stamps per dollar. Oops, put in a 0. So 7/5, so 3/4 or 75 hundredths stamps per dollar. Let's try one more, okay? This graph shows how the number of cakes Pedro can bake is related to the number of additional sticks of butter he buys. When I read my graph here, it's cakes baked. I notice my y-axis is the number of cakes, and my x-axis is the number of additional sticks of butter. We're asked to find the rate of change again. And in this case, our rate of change is we want to know the cakes per stick of butter. So cakes per stick of butter. All right, let's check out our labels here. So the number of cakes is our y-axis. And then the number of sticks of butter is our x-axis. Now that everything's labeled, everything's set up properly, what's our next step? Select 2 points on the line so we can see what that change is. We can determine how much it is changing over time. All right, I'm going to pick 2 points that are a little bit farther away from each other this time to show you guys that you really can select any 2 points on the line as long as it has an exact value. We don't want to do any estimating. So we'll go ahead and select the first one at 0, 10. And then we'll select one up here. So we'll do 20, 50. So 20 sticks of butter, 50 cakes. Now that the 2 points are selected, look back at the ratio we set up. We first need to know how much the cakes changed. So that number of cakes is your y-axis. We're going to be counting our our vertical change. So we started at 10, and my graph is counting by tens. You always want to see what your graph is counting by. It could be ones, fives, tens, in this case, tens. So I go up 10, 20, 30, 40. So from 10 cakes to 50 cakes, we increased 40. So we had an increase of 40 cakes. Now we want to know how much the butter increases. That's our x-axis. We're now looking horizontally. We started at 0 sticks of butter. My x is also counting by tens. That is important to check because they don't always count by the same amount. We started at 0, we increased 10, 20. So from 0 to 20, we increased 20 sticks of butter. All right. Let's reduce, let's simplify this fraction. Well, depending on, the factors and the multiplication facts that your brain comes up with, you may see an immediate simplification, or you may have to do a couple steps. I notice that they both have zeros, which means I can divide them both by 2, and we get 4 over 2. But that's not quite simplified enough, because for this entire assignment, it says cakes per stick of butter. We want to know the rate of change as a unit rate. We want to know it as one single unit. Well, thankfully, that can simplify again. 4 divided by 2 is 2. So we know that you have 2 cakes per stick of butter. All right. So now it's your guys' turn. Let's try this IXL assignment out. Remember, you can use this video as reference. You can also go back, check the notes, email me for help, and I'd be more than happy to assist. Good luck, guys. You got this.